Warm greetings to all of you. I am very happy to be here and extend my sincere thanks to the organizer of the 99th GWIS National Conference for providing me this wonderful opportunity. Today, I am presenting our research on substituted beta-lactams. I am going to discuss how fascinating this area is and how it can be serve humanity. Infectious disease are a serious problem in the healthcare system. These infections affect millions of people worldwide and are transmitted through microscopic single spores that can survive for long periods of time outside of a host, lying dormant in soil, air, and water. So beta-lactam antibiotics played a major role to overcome these infections. Now, antimicrobial resistance has emerged as a major challenge for current medicine and healthcare system. Antimicrobial resistance is a situation when antibiotics do not show desired effect. So antimicrobial drugs are used not only for human health care but also in animal health, crop protection, antifouling coatings, timber preservation, and this multiple uses has accelerated the independent evolution of resistance. Without effective antimicrobials, the success of major surgery and cancer chemotherapy would be compromised. So there is emerging need and urgency to develop and discover new promising molecules and develop innovative technologies for the alternative solutions. Our group is working to find out new chemical entities to avoid future critical failures in medicine and ability to control the microbial infections. So beta-lactam is an established pharmacophore with different pharmacological activities. So monocyclic beta-lactam is associated with the anti-cancerous activity, antimycobacterial activity, antifungal activity, antiprotozoal, anti-inflammatory activity, antioxidant activity, antidepressant activity. It also acts as carbonic anhydrase inhibitor, human neutrophil elastase inhibitors, cholesterol absorption inhibitors, and even as a herbicidal. So what is beta-lactam? The beta-lactam core represents a four-membered heterocyclic ring amide. The beta carbon and the nitrogen linkage form the heterocyclic ring, and therefore the heterocyclic system is named as beta-lactam. And the simplest beta-lactam is 2-azetudenone. The most common mechanism of antimicrobial resistance is cleavage of beta-lactam antibiotic by beta-lactamase enzyme. So to overcome this problem, our research group is focused on design and synthesis of more stable and harder to cleave the beta-lactam hybrids. Finally, impact of different moieties and substituents on pharmacological activity has been assessed in order to determine the structure-activity relationship, in which we found some exciting and interesting results. So significance of our work is that it will definitely have a great impact on pharmacological and chemical knowledge and may find value in health and medicines. So these hybrid molecules could be lead molecules to control antimicrobial resistance. So thank you. We synthesize organic molecules and we are open for collaborations for antimicrobial studies, bioinformatics, QSAR, Autodoc, chemoinformatics studies, anti-cancerous and other biological activities. Thank you so much.